In this video, I will show you how to work out the correlation coefficient using your calculator. Okay, so the correlation coefficient, remember, it's called Pearson's correlation coefficient. It measures the strength of the correlation between two variables. So take a mental mental photo of this table. Nah, jokes. This is on page 222 of your textbook. Okay, so we're going to need all these numbers in the table. Okay, and we have to add, because we have to enter them into the calculator in order to work out the strength of the correlation between, let's have a closer look, the length of someone's humerus, that is the bone from the elbow to the shoulder, okay, and their height. So naturally you'd expect there to be a correlation because most people are proportionate, right? So we're going to do that using the calculator, and while we're at it, I will show you how to work out the equation of a line. Okay, so in that diagram, I did this line of best fit. This is just by eye, so I didn't do it using any technology. Just roughly, you put the same number of points, okay, on either side of the line. And obviously there's a correlation because as one increases, the other increases. And we know that from the numbers. So someone with a humerus length of 37 has a height of 176. Someone who's got a shorter humerus, okay, 35 centimeters, their height is 174 centimeters. They're a bit shorter than this person. Okay, obviously there's a correlation. Now, this is a line of best fit, like I said, so it's approximate. And the best way to do it is to divide the data evenly on either side of the line, okay? But there's a better way of doing it, and that's using the calculator, where you get the equation of the line in the form y equals mx plus b or mx plus c. Yeah, same thing. So it's the gradient times x, so m is the gradient, so the slope, times x plus c. That means if you extend the line, where will it cut the y-axis, the vertical axis? That would be the value of c. Okay, so let's now do the calculator steps. So you need to go to page 222 of your textbook, have these numbers in front of you. Okay, so you can do them, enter them as I'm doing this as well on the calculator. Okay, right. Okay, so the first step in any question on data, okay, is to clear your statistical memory. Because if you've used your calculator for any data analysis, might have been whenever, those numbers will still be there and they will interfere with your results. So the way to do that is you press shift and then 9. See how there's CLR on top of 9? Okay, so clear. So shift and then clear. Okay, and then we want to clear the memory at this point. So just go to, and then equals means yes, you want to clear the statistical memory. And to complete the process, you press the AC button or clear button. Okay, done. That's the first step. Now you need to put your calculator in stats mode. So mode, right? And then number 2 is stats. Now look at all these options we have. So we want to choose the one that gives us an equation for the line of regression line. It is called median regression line, or there's another word for it. So the median regression line or the least squares regression line. Okay, so we have to choose this one, number 2, because that gives us the equation of the line. Okay, so let's do that. And then here we are, we've got 2 columns because we've got 2 variables. So enter the length of the humerus in x. So let's do this. 37 equals, you press equals after each number, 35 equals 40 equals 31 equals 35, and so on. Okay, so just enter these as we're doing this. Okay, let's scroll now to the y column, to the height. oops, let's go to the first number, first score. Okay, here's the first score. So we've got, what is it, 37. So the person with a humerus length of 37 is 176 centimeters tall. The next person is 174, and then so on, 184. We'll enter all of this. Okay, where am I up to? 189 is next, 180 and 188. Okay, now once you've entered all of the numbers, the measurements, you press the AC button, all clear, okay, and then you go, let me adjust this, okay, so then we're going to get all this data, okay, so we'll get A and B, capital A, capital B, to get the equation of the line, and we can work out R. So you go shift 1, okay, let's go down to 1, okay, see how 1 says stat on top, okay, and then you get all of these options again. So what we're looking for here is REG, number 5. Remember, it is called the median regression line, so that's what the REG for. 5, there we go. We can work out A, B, R, and even standard deviation. At this point, we just need A and B and R. So remember, at the very beginning, we chose A plus BX, because that's what's going to give us the equation of the line. So what I want you to do now, pick A, then repeat the process, pick B, repeat the process, and so on. So let's go, let's start with A, 1 equals. Okay, so that's A. I want you to write this number down, okay? So A is equal to 121.258. Let's repeat the process now. Shift 1, and then 5 for regression line. And now we will pick number 2 because it represents B, and press equals. So B is 1.61244. Remember, it's A plus BX, so B is the coefficient of X. Okay, now, one more time. So this is a separate thing we're doing now. It has nothing to do with the equation, writing the equation at least. So let's pick 3 for the correlation coefficient, and the correlation coefficient is 0.836, etc. So that's a strong positive correlation, which is what we expected. When the length of the humerus increases, or if the humerus is longer, then the person is taller, yeah? And so that's relatively strong, that correlation. It's not perfect, because not everyone is 100% proportionate, right? So it's not perfect, but it's a very strong correlation. Now, let's go back to why we found out the values of A and B as well. So R is not involved in our equation, but R tells us how strong two variables are connected or correlated. In terms of A and B, remember, normally, so I'll write down, I've got the value of A and B here. So A, remember, was 121.258. I'm going to round this off to 121.3. Let's do 1 decimal place, that's enough. And then B is 1.6124, etc. So let's say 1.6, okay? So remember, what we chose at the very beginning was A plus BX. Remember, the equation of the line is y equals mx plus b. So m, in other words, is capital B when we're working off the calculator, because that's the number attached to x. So if I'm going to write the equation of this line, I'm going to write height. So the height of a person, because that's, remember, that's the vertical axis. So the height of a person, okay, is related to the length of their humerus, x, I'll leave it as x, by b is 1.6, which is the same as m. So 1.6x, and that's humerus. I hope I'm spelling it right. Okay, plus b, the number that's on its own, which is a, yeah, which is in the formula that we're familiar with is lowercase b, plus 1 to 1.3. Okay, and there you go. That's the equation of the least squares line of best fit, okay, or least squares regression line, or trend line, or median regression line. Okay, so it's got a few names, but that's how you find its equation using your calculator. And you should watch the video on how to do that using a Google Sheets. And if you remember from the Google Sheet, we worked out r squared was 0.6999 on our calculator. Okay, so that's r squared, right? We worked out on the calculator that r is 0.836 ... If you take the square root of this, okay, so square root, so if r squared is this number, then r is the square root of this number. So let's work that out. You should get 0.86, yeah, 836, sorry. So square root 0.699 equals, there you go, 0.836, which is what we expected, right, 0.836. Okay, good luck. Do as many questions as you can so you can remember the calculator steps.